Okay, we've been studying kinematics, and we have talked about position vectors and displacement vectors and the difference between them. We know that position vectors are special displacement vectors that are referenced to the origin, and displacement vectors can be referenced to any other position. And we've drawn motion diagrams where we've put the time on the x-axis and position on the y-axis. And we've also found that you can take the slope of a position versus time graph to find the velocity. And we also learned that you can find the average velocity by drawing a line segment between any two positions on a position versus time graph, taking the slope of that line segment, and that's the average velocity between the two positions. Today we're also talking about velocity. And if you did not copy this down in your notebook because we didn't have time in class, I do want you to copy this down. And you can pause the video if I'm going too fast. I want to go through this pretty quickly. So motion can also be described with a velocity versus time graph. In a velocity versus time graph, you put the velocity on the y-axis and you put time on the x-axis. The velocity is the change in position per time interval. So we've written this equation, and this equation is v velocity is equal to delta d divided by delta t. This is delta d is the change in the position divided by the change in the time. So this is a mathematical equation. If you rearrange this equation, you can solve for the change in the position, or rather the displacement. So delta d is displacement. We remember this from the previous page. So the displacement is simply equal to the velocity multiplied by the time interval. So v times delta t. I've drawn an example of a velocity versus time graph, and I want you to draw this in your notebook. So on this velocity versus time graph, we have time going from 0 to 5 seconds, and we have velocity going from 0 to 15 meters per second. Now, these are horizontal line segments, and that tells us that for this particular time interval, 0 to 2, you have constant velocity, and it's at 10 meters per second. And then here we have a different constant velocity, which is at 5 meters per second. And we've already drawn some graphs that produce velocity graphs similar to this. Now, this idea of finding displacement by multiplying the velocity and the time can be applied directly to this graph. Velocity is the quantity on the y-axis, and time is the quantity on the x-axis. So if we look at each one of these line segments, they form a rectangle with the x-axis. And notice the velocity is the height of this rectangle, and the time interval is the width of this rectangle. And if you multiply velocity and time together, as indicated by this relationship, you get the area under this line. It's called the area under the curve, even though the curve is really a line. Same with this one. It's different. It's a different shape, but you still get an area. The area of this is the displacement during the time interval from 0 to 2 seconds. And the area of this is the displacement during the time interval from 2 to 5 seconds. If we add these two areas together, we get the total displacement from 0 to 5 seconds. So here's how you do it. You multiply the height times the width of the rectangle. 10 meters per second times 2 seconds is 20 meters, plus the height of the second rectangle, 5 meters per second, times the width, 3 seconds. 5 times 3 is 15. So 20 plus 15 is 35. So what that tells us is that the total delta t, the total displacement from the beginning, is 35 meters. the object is now 35 meters displaced from the original position. Okay, one other thing I wanted to point out, and that has to do with velocity, the sign of velocity. The sign of velocity is the direction of the motion. It really doesn't have anything to do with whether you're getting closer to the origin or further away from the origin. Here's a point. Here's a one-dimensional drawing of positions. This is a position graph. There's no times on it. And we're showing this person moving with positive velocity. If the person is located in the positive region, and this here is the origin, right here. This person's located in the positive region, and they're moving with the positive velocity. They're moving away from the origin, but they're moving in the positive direction. If they are located in the negative region, but they have a positive velocity, they're moving toward the origin. So it's the opposite, but they're still moving in the positive direction. So we don't correlate positive velocities with moving toward or away from the origin. We simply say they're moving in the positive direction. Same with negatives. If you have a negative velocity, you're moving in the negative direction. It doesn't mean you're moving toward or away from the origin. For your homework, you were supposed to do problem 1 through 4 from the word problems, and you're going to begin to paste those or tape those into your notebook, and you're going to put them on this, starting on this left-hand side, and you might be able to put problem 1 and 2 on here. And then if you run out of room, flip over to the next page and do it on the left, and then even the right side if you need it. Okay? All right. Good luck.